Remember when we talked about SOHCAHTOA? So we did sine, cosine, tangent. It helps us find missing angles, missing sides. Now, a way to extend these trigonometric skills and to go beyond 90 degrees, 180 degrees, 360 degrees, but also see how negative angles work, then we deal with the unit circle. That's what we're going to do today. Unit circle. And it takes those ideas that we learned previously, and it makes them work for all angles, including angles that they exceed the 360 degrees. So this is an introduction to unit circle. We're going to start from the beginning. So this is my unit circle here. And why is it called a unit circle? Because the radius of a unit circle is a unit. So it's equal to 1. If I draw a straight line and from the center, so I know that the distance of this line, of this radius, is equivalent to a unit, to 1. It's equivalent to 1. Now, if we know that the radius is 1, then we know that these points here, this is where is 0 degrees or 360 degrees after we complete the unit circle. This is going to be 90 degrees, so we always go anti-clockwise for positive angles. This is going to be 180 degrees, and this is our 270 degrees. I am going to also put the coordinates for these 4 points. So you have to think about it as the x and y axis. X is the horizontal axis, y is the vertical axis. So our points here, our coordinates are 1, 0. At 90 degrees is going to be 0, 1. 180 degrees, this point here is going to be negative 1, 0. And 270 degrees, this is going to be 0, negative 1. Okay, now let's say we have this point P over here, and we want to find its coordinates. I am going to draw a right angle triangle over here. This is my right angle triangle, and this is the angle theta. Now, having done the trigonometric ratios previously, I know that the hypotenuse, as we said before, is 1, and this is the opposite side. This is the opposite, and this is the adjacent. Now, the opposite side is the y, and the adjacent is the x. Okay, so we have y and x. Now, to find the coordinates of P, I can use the trigonometric ratios. I can start with the cosine of theta, the cos of theta, which cos is the adjacent over hypotenuse. So cos of theta is the x, which is the adjacent, over 1, which is the hypotenuse. So that means x is equal to cos theta, or cos theta is equal to the x. Now, to use the sine of theta, and I want to solve in terms of y, so sine of theta, sine is the opposite over hypotenuse. Opposite is the y, and the hypotenuse is 1. That means y is equal to sine of theta. So, instead of having the coordinates of P x comma y, now the coordinates of P are going to be cosine of theta for x and sine of theta for y. So instead of x and y, I have cos theta, sine theta. So instead of x, I have cos theta. Instead of y, I have sine theta. So if that theta is 45 degrees, then the coordinates of P is going to be cosine 45, sine 45. If that theta is 30 degrees, the coordinates of P will be cosine of 30 and sine of 30 degrees. Now, having this information, knowing that the opposite is now the sine theta, or the y is the sine of theta and cosine of theta. So basically, these distances now are these now distances. I can say that they are cos theta and sine of theta. Using the Pythagorean theorem, I conclude that sine squared theta plus cos squared theta is equal to 1 squared, which is the same as 1. So I concluded to this identity. Okay, sine squared theta sin cos squared theta is equal to 1, which 1 is the hypotenuse and 1 is also the radius of this unit circle. Okay, now a little bit more information about the unit circle. A unit circle has 4 quadrants. It has the first one, the second one, the third one, and the fourth quadrant. Okay, and as I said before, this is the 0 degrees or the 360 degrees, 90 degrees, 180 degrees, and 270 degrees. Now, having those coordinates, the 4 coordinates, 1, 0, 0, 1 at 90 degrees, negative 1, 0, and 0, comma, negative 1 at 270. Looking at what we've done before, we have the cosine theta and the sine theta over here. That means that the cos of 0 or 360 is going to be 1, or the sine of 0 degrees or 360 degrees is going to be equivalent to 0. Since we've shown before, we had our point P over here, and we have shown that the coordinates of P is cos theta, sine theta. You can imagine it as cos theta is the x, sine theta is the y. So cos of 0 or 360 is 1 in this case over here, or the sine of 0 or 360 is 0. Now let's do the same for 90 degrees. 90 degrees. So cos of 90 degrees is 0 and sine of 90 degrees is 1. You can check that also on your calculators. The cos of 180 degrees is negative 1. The sine of 180 degrees is equal to 0. And last but not least, the cos of 270 degrees is equal to 0, and sine of 270 degrees is equal to negative 1. Negative 1. Very nice. Again, I will remind you that we go anti-clockwise when it comes to the unit circle. So, for example, if this is 30 degrees, or let's say theta degrees, if we have the same point here, which I will call Q, and then we have the equivalent angle over here, theta. This angle theta, the new one, is the same as saying angle is 180 degrees minus theta. So if angle theta is 30 degrees, let's say, and this is also 30 degrees, this angle that I'm going to draw now, this one, this angle here, is going to be 180 degrees minus theta, minus 30 degrees. So this angle here is going to be 150 degrees. Okay? This angle here, all the way to the 3/4 of the circle, is 270 degrees. And one whole round anti-clockwise is 360 degrees. I will also mention two very important triangles. These triangles that are very important is the 30-60-90 triangle and the 45-90-45 triangle. Let's have a look at the 30-60-90 triangle. So opposite the 30 degrees is the smallest side, in this case is x. Let's call our triangle A, B, and C. So obviously opposite the smallest angle is going to be the smallest side. So it doesn't look like the smallest side, but it is. So x is the length of AB. So opposite the 60 degrees is we're going to have the root 3 times x, or x root 3. So it's root 3 times bigger than x. That is the opposite side of 60. Now the hypotenuse is always double, is always twice as big as the smallest side, which is opposite the 30 degrees. So it's going to be 2x. Okay, this is here is just a reminder that tan theta is the same as sine theta divided by cosine of theta. Now let's go, based on this triangle, let's go and have a look at the sine 30. So sine 30, we know that is opposite over hypotenuse, which is x over 2x, which that gives us, if we cancel out the x's, to 1/2. So sine of 30 is 1/2. Now, cos of 30, which is adjacent over hypotenuse, cos of 30 is going to be adjacent, which is x root 3 divided by 2x, which is the hypotenuse. If I simplify this, I cancel out the x's, I am left with root 3 over 2. Sine 60, which is the opposite over hypotenuse, which is x root 3. X root 3 divided by 2x. I'm going to simplify those. I get rid of the x's. So I have root 3 over 2. And the cosine of 60 cosine, which is adjacent over hypotenuse, which is x over 2x, that simplifies to 1 over 2. I have a 45, 45, 90 triangle. Since I have two angles of 45 degrees, that means that my triangle is also isosceles. So I'm going to call these sides x, x and x. So if we want to find what x is, we can actually do the Pythagorean theorem here. I have a right angle triangle. That means x squared plus x squared is equal to 1 squared, which is equal to 1. That means 2x squared is equal to 1. X squared is 1 over 2. That means x is root 1 over 2. I have plus and minus normally here, but I know that regarding distances, I'm only going to leave the positive sign. Okay, if I want to simplify this, that will be 1 over root 2. And if I don't want to have the denominator under the square root, I multiply by root 2 over root 2. Then I have x is equal to root 2 over 2. So x is root 2 over 2. That means the sine of 45 will be opposite over hypotenuse, which is x over 1, which is, since we know that x is root 2 over 2, it's going to be root 2 over 2 divided by 1, which is root 2 over 2. And this is the sine of 45. The cosine of 45, which is adjacent over hypotenuse, again, now it doesn't matter which angle of 45 you get, you're going to get the same result. So it's going to be again x over 1, which is root 2 over 2. Now, why are these triangles helpful? They're helpful because they help us find the most important angles in a unit circle. Once we know the 30, 60, 90 angles and their sines and cosines, we can find any angles, sine, cosine, or tangent, or trigonometry, any other trigonometric ratios. For example, here, let's say I have a 30-degree angle over here. I've got also a 45-degree angle. And I have a 60-degree angle. So 30 degrees, 45 degrees, and 60-degree angle. So remember, first we have the cosine theta and then the sine theta. So here I have the cos of 30 degrees, we just found out, sine of 30 degrees. I have the cos of 45 degrees. These are the coordinates at each point over here. And the sine of 45 degrees. And I have also the cos of 60 degrees and the sine of 60 degrees. And we have just found these values. So the cosine of 30 degrees is root 3 over 2 and the sine is a half. So here I have root 3 over 2 and sine 30 is a half. For cos 45, we found that it's root 2 over 2, and the sine 45 is the same, root 2 over 2. And for cos 60, I have 1 half comma root 3 over 2 for sine 60. So basically, the only, if you notice, the values that we have here is only a half, root 2 over 2, and root 3 over 2. And these numbers are repeated, if you have noticed. It's interesting to see that here we're dealing with a cos and sine, and now we have, in this case, the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The cos and sine values for the first quadrant, they're all positive. Positive cos and positive sine. Okay? Imagine that as the coordinate plane where you have on the first quadrant positive x and positive y. Now when it comes to the second quadrant, I have cos and sine again. However, here the values for cos are negative and the values for sine are positive. The x values are negative, the y values are positive in the second quadrant. Third quadrant, cosine will be negative and sine will be negative. So both negatives. And on the fourth quadrant, I have again cosine, and cos will be positive and sine will be negative.